All right, 1997 BC 17. Let f be the function given by f of x is ln of 3 minus x, the third degree Taylor polynomial for f about x equals 2 is which of the following series? Now, I'm not sure if ln of 3 minus x is something that we would be able to know as off the top of our head, but let's go through what we would do in the event that we don't know. Right? So we start off with f of x is equal to ln of 3 minus x. And at x equals 2, f of 2 is equal to ln of 3 minus 2 is ln of 1, and that is 0. So then let's find the first derivative of that. Well, the first derivative is going to be 1 over 3 minus x. By the chain rule, you still need a negative 1 in there. And f prime of 2 is going to be negative 1. So I also may want to rewrite this as negative quantity 3 minus x to the negative first power to find the successive derivatives. All right, next, second derivative. Well, when we bring down the negative 1, we're going to get a positive, so it's 3 minus x to the negative second. However, by the chain rule, we still need a negative 1, so that's going to be negative 3 minus x to the negative second, and f prime prime of 2, second derivative at 2, is going to still be negative 1. So we have 1, 2, since the first term is 0, we need one more term here. So the third derivative at x is going to be, to bring down the 2, and it's going to be positive, but then we're still going to end up with a negative 1 here, so it's still negative 2 times 3 minus x to the negative third. Now when we plug in x equals 2, we are going to get a negative 2 here. So just by looking at the coefficients, we may be able to tell something. Actually, we can see that only b has all negative terms, which is what we should wind up with. But we don't see the 2 in there, for example. So what we want here is f of 2 plus f prime of 2 over 1 factorial times x minus 2 plus f prime prime of 2 over 2 factorial times x minus 2 to the second power. And finally, third derivative at 2 over 3 factorial times x minus 2 to the third power. All right. Now, actually it says that f, now when we construct these, the first one is 0, so we are going to have a 0 there. Second one is negative 1 over 1 factorial. Obviously, it's x minus 2 plus. Now, just from looking at that, we can tell that c, d, and e are not valid there. And we go on to the next term, which would be the second derivative. That's going to be negative 1 over 2. So that would be, so that's going to be negative 1 x minus 2 to the second over 2 factorial, which is 2. And so we could almost stop at that point because the x minus 2 to the second over 2 is positive in a. But let's just do one more to just check this out. The next one, we have the third derivative, which is negative 2 over 3 factorial times x minus 2 to the third power. Now, we don't have something that looks like that, but remember that 3 factorial is 3 times 2 times 1, and so the factors of 2 will cancel, and we will end up with So we have just 1 over 3, or x minus 2 to the third over 3, giving us selection B there. So this takes a little while, but you do have to be able to go through the process of constructing a Taylor polynomial relatively fast and putting it back together to match one of the given answer responses. So that will be it for this one.